In this video, I want to show you how to produce digital elevation model of any location from elevation data. Of course, digital elevation model is available online for any location. However, there are sometimes you may need to produce digital elevation model from elevation data you collected from field. So in this video, I want to show you how to do that from scratch. I'll show you step by step, and I'll also show you the shortcoming of this method. Now, for example, I went to the field, and in my study area, I collected the longitude and latitude of points and the elevation of each point throughout my study area. And in my study area, I have collected about 979 points. Their elevation, longitude and latitude. So you can see I have a lot of points from my study area. Now I want to use this data, which is elevation, to produce the digital elevation model of my study area. So to do that, after you have collected your points and enter it in Excel, you have to save it as CSV. So to do that, come to File, click on Save As, navigate to your working folder. Let's save it as elevation data, for example. Then choose your format here. Choose CSV, delimited. Then click on Save. Click on OK and click on Yes. So we have saved our data as elevation data.csv. Then we can close this. Now after you have saved your data, then open ArcGIS. In ArcGIS, this is the boundary of my study area, and I want to use the elevation data I collected throughout this study area to produce the elevation model of the study area. To do that, come to File and bring in the CSV data we saved the other time. Click on File, come to Add Data and click on Add XY Data. Then click here to navigate to your working folder. So I will go to the folder where I save that elevation data, and here is it, elevation data.csv. Click to select it and click on Add. Then here, make sure you specify X as your longitude and Y as your latitude. Then choose your coordinates reference system here and click on OK. Click OK. You can see that I collected the elevation data throughout the study area. You can see the number and how evenly distributed those points are. So the more points you take, the more accurate your results, and the more spread they are, the more the accuracy. So when you collect your data throughout your study area, it will be very okay. But however, if your data collection is concentrated only in one location, that will give you a very poor result. Make sure when you go to field to collect your data, you go throughout your study area to collect the data. Make sure the points are dispersed, so don't let it be choked in one place. So after this, we have to convert it to shapefile. To do that, come to this elevation data, which is just an event. Right click and come to Data, then Export Data. Then click here to navigate to your working folder. So let's save this as elevation points. Then choose the format as shapefile and click on Save. Then click on OK. Click Yes to add it to your map. Yes, it has been added. Then you can remove this Excel format. Yes, we have our elevation points now. If I right click and open the attributes table, you can see the points, you can see the latitude, longitude, and elevation. At this point, our major concern is on elevation. So let's close it. So to use it to produce the digital elevation model of this area, come to Arc Toolbox, then come to Spatial Analysis Tool, come to Interpolation. What we want to do, since we have collected elevation of each of these points, we want to use those points we know to interpolate to know the elevation of other locations we have not captured. That is the essence of this interpolation. And the technique we want to use is IDW. So double click to open this IDW. Then here, input point feature, we are going to input our elevation points. Click to select it. Then Z value, that is the field we want to use to interpolate. And in this case, click on this drop down, select the elevation field. Then our output raster, click here and navigate to your working folder. So let's call it Digital Elevation Model. Then click on Save. Then the cell size, leave it at default. Then at this point, we have to set the environment. To set the environment, click on Environment. Then come to Processing Extent. Then the extent, select the boundary of your study area. Then scroll down and come to Raster Analysis. Come down here, under Mask, click on the drop down and select your study area boundary. Then click on OK and click on OK. So this will run and interpolate this point to find the value of elevation for other areas that were not measured. Yes, it is done. Then we can now close this point. Then if you look at it, let me close this point. If you look at it, you can see that it has interpolated for other areas where measurements were not taken. But to view it as digital elevation model, right click on the DEM you created and come to Properties. When it opens, come to Symbology. Now instead of Classify, click on Strength. So you can see the highest value and the lowest value. Then click on OK and you can see this is the digital elevation model of the area ranging from 1.0 to 255. Now the shortcoming is this: the more points you collect on the field, the more accurate your result. And if you collect few points on the field, then the software based on the known points you have given to it, we use it to suggest the value of other areas. So the most important thing is that when you go to field to collect your data, elevation data, make sure you collect your data across the study area. If you collect few points, then your results will be highly inaccurate. But if you have a lot of points collected and well distributed across the study area, by the time you interpolate, you will get better results. But in essence, this is how to produce digital elevation model of any location using elevation data collected from different points across the study area. Thank you for watching.